So similar to the last chapter, remember how in the last chapter the first thing you did was just determine is it arithmetic or geometric? The first thing we are going to do is determine if our parabola is vertical or horizontal, okay? You can't do anything if you don't know if it's vertical or horizontal. The way you determine if it's vertical or horizontal is just by looking at like the blank equals, if it's y equals or if it's x equals. If it's y equals, everything is in terms of x, meaning that whenever you plug in x, you're going to get 2 y's. So, or, yeah, no, the other way around. You're going to plug in, like if you plug in like 2, you'll get 4. And if you plug in -2, you'll get 4 as well. So 2 x's will create the same y. That's what I meant to say.
I'm a little lost now after that.
If I were to like plug something in for x and square it, there's 2 things that I could plug in and square and get the same y. So they're going to create like points like this.
Right, okay, got it. That was just a little...
But basically, if it starts with y, it's going to be vertical. If it starts with x, it's going to be horizontal. So in this case, it starts with y. So since it starts with y, this is going to be a vertical parabola. We know it's a parabola because y is not squared and x is squared. It's the only conic section that has one variable not squared and one variable squared. And so that's how you'll determine the difference between a parabola and like anything else.
And a parabola.
The next thing we're going to determine is like the direction of opening, because again, if we know the direction of opening, we have a general idea of what it looks like. So because this is negative, it's going to go down. If it's positive and it's vertical, it would go up. So it's vertical and it's going down. We'll get to horizontal ones, but just in case you're wondering. For horizontal,
how did you know that
if A is positive, it goes to the right, and if A is negative, it goes to the left. We just did vertical. If A is positive, it goes up. If A is negative, it goes down.
It go down.
Like think positive, happy face. Negative, frowny face. Happy face.
So what about
frowny
horizontal?
face. I don't know. Positive meaning going to the right, negative to the left. Like left x negatives go to the left. Right. I don't have a cutesy thing for that. All right. Once we determine it's vertical and down, we have like a general picture in our minds. It's gonna go something like that. I don't know. I don't know where it is, but it's gonna look like that. We're gonna start with the vertex. We started with the vertex before. We're gonna start with the vertex now. So the vertex is found by looking at whatever is next to x or y, and then whatever's on the outside. So since this is vertical, or yeah, whatever's next to x, that's going to be our h, or our x coordinate of our vertex. So there's a 1 here. Whatever's being subtracted from x, that's the x coordinate of our vertex. Remember, it's opposite. And then if there's something on the outside, that's going to be our y coordinate of our vertex.
I still remember this.
I just like, I don't remember what's happening right now. I'm like lost a little bit.
This is all review.
No, only because like I was like trying to like write stuff down, and then I look up and we're a completely different thing.
Whatever's next to x is your x coordinate of your vertex. Whatever is on the outside, that's your y coordinate of your vertex. So this is h, this is k.
I knew that then.
You should know that because that is from chapter 4. All right, so that's our vertex. In some cases, you don't want to graph it right away because you might want to scale the graph. I'm going to tell you, just for the sake of saving time, you don't have to worry about that. Go ahead and graph it. And then you want to label it because we're going to be graphing other dots too, and we don't want to confuse our vertex from our focus or other points. Oh, it's not 1 over. Yeah, just kidding. There we go.
It's going down, right?
Yeah.
Thank
So
God.
the rest of it is going to be like something like this. I don't know exactly how, but something like that. You can put those dotted lines there if it's going to help you through the problem if you want, just like lightly in pencil or something. Or you could just do this, like, right? Like just like the start of it. The next thing we're going to find is, and it's kind of up to you, it doesn't have to go in any particular order, either the focus or the directrix, but they're both found in similar ways. So I usually find the focus next. So my focus,
This is vertical, so it's
go ahead and look at your diagram.
H comma K plus or minus 1.
Don't worry about that part. That's gonna be too hard to memorize. How far is your focus from the vertex?
1 inch.
No.
Half, no.
Oh, 1/4A.
1/4.
Oh, I thought you were talking about.
So the distance from the vertex to wherever the focus is 1/4A.
Mm-hmm.
What is A in this equation?
Negative. Oh man.
Hmm?
That's a gross A.
No, it's not. It's good.
Oh wait, it's just gonna be
So
2.
if A is -1/2, then this distance
is negative half.
So 4 times 1/2 is what?
-8.
It's negative 2.
-2. So the focus is gonna be 1/2, and since it's negative, it's gonna be 1/2 below your vertex. So the distance from vertex to focus is -1/2. That's what we just calculated. So if your vertex is here,
Yeah.
That just happened to be the same as A.
I don't think that was like a I think that
yeah,
was
well,
just
you
like
know how twos work, they're like special.
They're like
But yeah,
special.
it's a coincidence.
So
We're gonna go 1/2 below the vertex and put a point. That's my focus. Now,
It's really small.
where is that focus?
you went like literally 1/2 down.
So where would it be?
1, 3.5.
1 and 3.5. Because it's 1/2 below 4.
Can I write 3.5?
I wrote 3.5 literally.
Now remember when we were doing our little activity, the directrix and the focus are the same distance away from our vertex. So if I wanted to draw a directrix, how could I do that? If I know that this is 1/2 below, where would the
Have to go
directrix be?
Another half
above.
1/2 above, so right around here.
Oh man, I wrote the word vertex there.
That's okay, just put it, go like this, like me, and then pick back up on the other side of vertex.
I already erased it, it's too big. I also, okay, it's fine.
My graph is all like out of whack.
It's hard to make it look pretty is the problem, and I'm
No,
like
it's
so.
not that. It's just like I don't know.
Once you do a few of them, it'll be
I don't
easy.
know how.
I think I'm so OCD about my notes that like this is giving me anxiety.
Where did we just put that line? What is it going through?
It'd be 1, 4.5.
But it's a line.
It's going through
Oh, the x-axis, the y.
It's going through
x equals
Y equals
5.5.
4.
Oh, y 4.5. Wow, I can math, I promise.
So it's above the vertex at y equals 4.5. It's y equals because it's a horizontal line. If it's a vertical line, it's x equals. Okay. We have directrix, we have vertex, we have focus. What are we missing?
Axis of symmetry.
We are missing the axis of symmetry. We can put that in whenever we want. Remember, the axis of symmetry goes through the vertex and the focus. So it's going to be a vertical line in that case.
Now we're just
It's gonna be a
missing-
vertical line at x equals 1.
Now we're just missing
Yes.
our 2 points. That make
Good.
the
Vertical
problem.
line through x equals 1. What else are we missing?
The points that make the parabola.
And how did we get those?
We went 1/4A to the side.
Kind of. What is the thing? What is the chord?
The lattice.
Lattice rectum.
That's what.
And how long is the lattice rectum?
Half of the
2.
I don't know.
1A.
One-
1
one
over
A.
8.
It's 1 over A. So what's A?
So it's 1
Negative
over
1/2.
-1/2.
And it's an absolute value because it's a lane. So what's 1 divided by 1/2? 2. So the lattice rectum is 2 units long in total.
2 units, so that's 2 squared.
No,
No,
it
it
just
means
means
go
that the
over
whole
2.
thing is
Oh.
2. Well, it means that if the whole thing is 2,
You have a 1.
we're
Does
gonna
it come out of the
go.
focus? What does it come out of again?
It goes through the focus. We're gonna go 1 unit to the right and 1 unit to the left.
Oh, the
so
whole
that
thing
the
is
whole
2.
thing is 2.
Oh, okay.
Okay.
That would make more sense, right?
So, because the whole thing is the latus rectum, so when we draw it, we're drawing it like a half at a time so that it's symmetric. You know, if we went 2 to one side, we'd have nothing on the other side, and then it wouldn't be symmetric, it'd be this awkward
It'd be this awkward.
thing. That doesn't make sense. And if we do 2 on both sides, then you're saying the latus rectum is 4, which is bad. You can put little points on the end of the lens, right there. Those are points on our parabola, and then we're just gonna connect our vertex to those points in the best way we can to create our parabola. And we're gonna attempt to make it like rounded at the top. And I guess you could like keep going here.
So we don't need to find points as we did.
Well, you're technically finding 3 points. You find a vertex, you find this guy, and this guy.
Wait,
Oh, then
you
we're
put the
fine.
lattice rectum below the vertex?
That looks terrible. What's wrong with me? What?
You put the lattice rectum below the vertex?
It goes through the focus.
Or was it, okay.
Always. It always goes through the focus.
Dude, why am I like terrible at drawing parabolas today?
So do you see how we like identified as we went along? The first thing was the vertex. Then we drew the focus after calculating whatever 1/4a was, and then we filled in where it was. Directrix is similar, just on the other side of the vertex. We put where it was. Axis of symmetry always goes through the vertex and the focus. And then the latus rectum is 1/a in length. So it's
Very
always a length. So we just look at the positive value.
I'm just so bad.
So yeah, if there's no parentheses, then whatever's next to x has to be a 0. It's like x minus 0.
That's what I figured, and then I like got dumb.
Which way is this opening?
Oh, I got it right.
Upward.
Up. It's important to know which way it's opening, because otherwise you're not going to know where to put the focus.
And it's a parabola.
Where the focus is related to where it's opening. The focus is always going to be inside the opening of the parabola. Okay? And the because it has to be inside because the latus rectum goes through it. That's what creates the parabola. The directrix is always behind it, not touching it. So the directrix never touches the parabola. The focus is always inside of it.
You
It's
said
like
going up.
the pearl in the oyster. And this is like the ocean floor.
Mm.
You said me.
I have no idea what I do with this voice. Okay, so the next thing we're gonna do is we're gonna do some calculations. We're not gonna graph anything yet. We're gonna just do calculations. So the first calculation we do is for these two, and it's 1/4a. What's a? It's
One.
not a variable. It's a leading coefficient,
1.
1.
Oh,
What?
So what is that? 1/4 times 1.
1/4 times
A
1
fourth,
over
yeah.
4.
So a fourth. A fourth is how far the focus and the directrix have to be from the vertex. That is a very small distance, which is why we're going to scale this later. Now, if you're thinking of the focus, and we know this thing is opening up, would it be a fourth above or a fourth below the vertex?
It'd be a fourth above.
It'd be a fourth above.
How do you know?
Because it's
it's
going
gotta
up.
open, if this is our vertex, the focus has to be here and directrix has to be here. So if it's a fourth above, it's gonna be a fourth higher than -2. Do you know what that is?
Yeah, it's like right there.
What's
I don't
a
know the
fourth
exact point.
higher than -2?
1
1 and 3/4.
I don't know how to do that.
7/5.
Like in my head.
You're just adding a positive fourth to -2.
I'm so bad at that.
You just subtract 1/4
From 2.
and then make it negative.
Make it negative. Now the directrix would have been a fourth below -2.
So it'd be plus.
It's -2 and
Negative.
1/4.
-2 and 1/4. And it's going through it's horizontal y equals. So just like a little hint in case, because it's gonna start getting confusing, the directrix and the equation always share like the variable. So if it's an equation of y equals, the directrix is gonna be y equals.
So it's like x equals, it's horizontal.
Right.
And it would be
So the directrix tells you, like the letter that's in front of the equation is gonna tell you the letter that's in front of the equation too. Now your axis of symmetry always goes through your vertex and your focus.
So
Look at the vertex and look at the
0.
focus. It's going through the x value of 0. And then the latus rectum is the reciprocal of A, and I'm going to keep phrasing it that way, the reciprocal of A, because it's easier. So if it's 1/2, what's the reciprocal of 1/2? There you go. See how it's easier than saying 1/A?
So the reciprocal of
So
A
the
is
reciprocal of 1 is what?
1.
1. So the reciprocal of 1 is 1. So our latus rectum is going to be 1 unit long.
So we just have to do that.
Yes. So now, if we're gonna graph it, instead of making like each one of these like 1, I think I'm gonna do. So I only have 7, so I'm gonna do like this as 1 and this as 2. So every 2 is gonna be 1. That's how I'm gonna scale it.
Oh, oops.
If you have enough, it's sometimes good to make every 4 1, but I don't have enough because this only goes up to 7.
If we're doing this on the quiz, can I just like do like the outer box and say this equals like 1/2? Like, you know what I mean?
I don't know what you mean.
So like you know where you marked 3 over on the far right?
Mine like
Yeah, and
only
then
goes
just
like
like mark
2
that part and then
boxes.
the end part and say, and then draw a line
You
saying
just
that.
have to label it. I have to be able to understand it.
Yeah.
So if our vertex is at 0, -2, that puts my vertex here. And I know from the beginning that this is going to open upwards because A is positive and it's a vertical parabola.
Our focus is 1/4 above.
Our focus is 1/4 above. I'm going to draw him in blue. So 1/4 above. If this is a 1/2 above, a 1/4 above would be like right here.
Oh.
And then our directrix is a 1/4 below. So that's going to be here. Oh, that was terrible.
Will the lattice rectum just be 1?
Yeah. Well, it's 1. Yeah.
Our latus rectum is in total 1, so to graph it, you're going to go a 1/2 in each direction. Since I scaled this, one little block is actually a 1/2, and one little block is actually a 1/2. Yeah.
If we don't scale it, that's fine.
If you don't scale it, it's just going to be really hard to graph. It's going to be really small. Okay, after you graph your lattice rectum, you're going to put like little dots and just connect your vertex to those dots and go upward.
Just so bad.
Yeah, you don't have to scale it, but if it's this small, like, it's just gonna be not accurate whatsoever. Because it's gonna be like too smushed. But in theory, I do try to avoid some fractions, but you can't really avoid all of them. They exist, you have to deal with it. It's part of the thing. But if you scale your graph, you can, you know, let's say the lattice rectum, or let's say A is like a 1/3, then you can maybe make each block a 1/3, so that 3 blocks is 1, and then maybe avoid some stuff that way.
Oh my god, I put my lattice rectum on the vertex instead of.
So in a horizontal parabola, your vertex has to be identified backwardsly. But before you start picking stuff out, you want to first just figure out that it is horizontal. So what tells us that this is horizontal?
The X.
Yeah.
I mean, yeah.
No, yeah. The fact that it starts with X equals tells us that it's horizontal. And if A is positive, which it is, because it's positive 1/4, that's telling us that it's opening to the right. So if A is positive, it opens to the right, and if A is negative, it opens to the left.
So it's positive, so it's open to the left.
To the right. Positive opens to the right, where the X's get positive.
So when you're right, you're positive.
Yeah.
That's how it goes, I guess.
Yes. All right, so now for the vertex. Do you see how 5 is next to y and it says y minus 5? That makes 5 the y coordinate of your vertex instead of the x coordinate of your vertex.
Because it's opposite now, right?
Which way is it
Oh,
facing?
Right.
This is just so
So the x coordinate will be just.
Now there's nothing out here. Usually there's something out here, right?
Which is
Like a
0?
plus something. Right, since there's nothing out here, it's like we're adding 0. That's on the outside with x. So he is your vertex for your, oh, blue.
So then it'd be 1
Oh yeah, never mind.
4 times 1 4
Huh? Wait, no. 1 over 4 times a.
times 1 4.
4 times 1. Yeah. So our vertex is at 0, 5, somewhere up here. Let's graph it. Here. I'm just going to put a little V next to it.
So it'll just be 1.
And we know it's opening to the right, so something like this. Just getting like a sketch.
God, I need to write mine down. Hold on.
So after you find your vertex, you're going to start doing calculations. The first calculation we do is 1 over 4a. A is a fourth. So 4 times a fourth is 1. So this whole thing is 1. 1 over 1 is 1. So the distance
I freaking use this graph.
between your vertex and your focus is 1.
How did you have 1 4 A? Oh, the 1 4. Okay, I was like, wait, what?
So like 4 times a fourth is
The
1.
focus
1 over 1
is
is 1. Focus isn't 1. It's 1 away from our vertex. If our vertex is here and it opens to the right, where would the focus go?
On the 1 like 1.
Right.
Vertex.
So our focus would be
Are
1
you
unit to
kidding
the
me?
right of our vertex. Because remember, the focus is like the pearl in the oyster.
And then
So
directrix is
our
what I
focus
learned.
is at 1, 5. Because it's 1 to the right. If the parabola is opening to the right, the focus is to the right.
So you just add to the x value.
Yeah.
Right.
Mhm. Now the directrix is the same distance away, just on the other side. So that would put our directrix right here,
So
1
it'd be
unit
negative
to the
1
left.
5.
Well, remember the directrix is a line.
I know, but I put the line there, the point here, and then I draw the line.
X equals.
So it's at x equals negative 1. You don't need the point, it's just a line.
Let me know how I draw a crooked line with the ruler.
Yeah, I've been doing that too, and I've been kind of questioning myself.
So you know it's x equals because it's going through the x value and it's vertical. And also, remember I told you before, if the equation starts with x, the directrix will also start with x.
So it's x is equal to negative 1.
Remember that our axis of symmetry goes through the vertex and the focus. So the axis of symmetry is going to be what? A horizontal line or a vertical
A
line?
vertical.
It's y equals 5.
Right?
Horizontal.
That's what I meant.
Yeah.
I knew it went that way, I just don't remember.
And then what does that go through? 5 in the what? X or y?
X.
Why?
Y.
Oh.
Horizontal is y. And it's going through the y value of 5.
I thought this was a I keep getting them confused.
Remember the axis of symmetry and directrix are always perpendicular. Now our latus rectum is
The
the
axis and the
reciprocal of A. So what's the
4.
reciprocal of A? 4. So it's 4 units long in total. So this one's a long, he's a big boy. If we want it to be 4 units total, we're gonna go to our focus and we're gonna make a chord that's 2 and 2. How do I want this chord to look? Do I want it to be a vertical looking chord or a horizontal looking
Vertical.
chord?
This way.
Vertical. So it's gonna go 2 above and 2 below, like
Oh,
that. So that the whole thing is 4 units long total.
Very cool, honey.
Then we put little dots right here, here, and then now we make our parabola.
I've never lightly off the graph. Yes.
Yeah, it does. You just stop it there.
Ew.
Yeah, mine like stops. So.
That's okay.
It looks kind of gross like that, Ms. Rapp.
Stop being so judgmental.
Yeah, everything.
Thing we can talk about is the vertex,
That's
which
the
is
only
at,
thing you got right.
this is the x, so it's at -3, and then this is the y, and
Well,
it's
how
at
does it be
1.
negative 8 units long?
Oh, wrong thing.
There's only 7 things on the graph, so I don't know what you did wrong.
Which direction is it opening?
To the left.
It's to the
To the
left.
To the
So
left,
it's
to the
opening
left.
this way, which means somewhere over here is a focus and somewhere over here is a directrix. That's the first calculation we'll do. So our first calculation is 1/4A. You can put the negative in there if you want.
Oh, that's what I.
How do you find your directrix? You know what? You know what?
It's gonna be
If
the
you're trying to- If
opposite.
you're trying to focus, it's just the opposite.
Yep.
Yeah, but equation wise, like. how do you
1/4.
1/4A.
Okay.
So 1/4A is -2. That means that the focus is -2 units away from the vertex. Since this is opening to the left, the -2 is referring left to. So the negative is referring to the left portion of that, and then it's gonna be 2 units this way. So 2 units to the left of our vertex is where the focus is. So the focus is at -5, 1. The directrix is gonna be the same distance away, just on the other side. So the directrix is gonna be going through this point, but it's not a point, it's a line.
Yeah.
So the directrix is at
-1.
x equals -1. And our axis of symmetry goes through both the focus and the vertex. So it's got y equals 1. And then what's the last thing we have to find?
You have to find the lattice rectum.
Lattice rectum is the reciprocal of A units long.
But like my question is,
It's
if it's
-8.
No, it's 8.
It's
A.
a
Absolute
measurement.
value.
Yeah.
It's absolute value. It's a length. So
that'd be on
length
the
can't be
focus,
negative.
right?
Yeah.
So it'd be
So it goes-
4.
Yep. So 1, 2, 3, 4. It's gonna be 4 this way, and then 1, 2, 3, 4, 4 this way.
I did it.
Why is that when you do it makes so much sense?
And when I do it, just.
I like
It's sort of like a process, and I go in a certain order because that order makes sense to me. And I think that's, what the heck? Why is it so ugly?
Mine's actually really pretty. Look how pretty
Like,
mine is.
you have to start with the vertex because everything is in relationship to the vertex.
I don't know. Mine's just.
And you have to know which way it's opening. So that's why I do vertex and then I put the opening in there. Then I know where to go. Wherever it's opening, that's
I
where the
was
focus
yawning.
is. So the opening and the
How?
focus direction are the same. And
You
then
don't see
every
that